Welcome to the training module on RF IF amplifiers from analog devices. This training module will introduce ADI's RF IF amplifier products and their benefits. RF IF amplifiers completes the RF signal chain available from ADI. The amplifier family has state-of-the-art performance in that there are parts specified for both broad and narrow band applications, which shortens time to market, eases device selection by designers, lowers manufacturing costs, and simplifies component evaluation, which all help streamline supply chain management and logistics. The RF IF amplifiers complement ADI's RFIC portfolio by supporting any RX-TX signal path and addresses any radio architecture and air interface standard. The entire RF IF amplifier family has world-class performance. The amplifiers are optimized for the highest linearity applications and are available in the industry standard SOT89 package as well as in the smallest footprint packaging. Every amplifier has an internal active bias, and most amplifiers include internal matching. The amplifiers are designed to meet the highest levels of ESD sensitivity. Each amplifier is fully characterized across temperature, power supply variation, and frequency. Fully specified data sheets help reduce design cost and time by minimizing the need for device characterization by design engineers, which speeds the design process. The amplifier designs also focus on reducing external components to further reduce cost and space. The first family of amplifiers we'll introduce are the low-noise amplifiers, LNAs, which offer unprecedented performance and flexibility. The ADL5521 and ADL5523 offer broadband operation from 400 MHz to 4 GHz. The ADL5523 provides the low noise figure of 0.8 dB, which includes the two-component external match, while accomplishing a high gain of 21.5 dB. Both LNAs have an adjustable bias, which can be optimized for 3 volts to 5 volt operation, and supply current from 60 mA to 30 mA or lower. Their datasheets characterize the LNA over frequency at 2 bias points, 5 volts 60 mA and 3 volts 30 mA. The ADL5523 offers high linearity with 0.8 dB noise figure on just 60 mA. The graph on the left shows the detail our datasheets go into for gain, OIP3, and P1dB versus temperature and frequency. The graph on the right shows noise figure distribution for multiple parts. The next amplifier family is their intermediate frequency amplifiers, IFAs. These amplifiers are optimized for the low frequency range of 20 MHz up to 1 GHz. Each IFA is fully specified in the datasheet at all common IFs. The IFA family also provides extremely high dynamic range by achieving very low noise figures and very high OIP3 simultaneously over frequency. The IFAs require few external components since the amplifiers are internally matched to 50 ohms at the input and output and have an internal active bias. The ADL5535 and ADL5536 SOT89 IFAs have a very wide dynamic range. These IFAs also provide best-in-class OIP3 versus frequency and best-in-class gain flatness versus frequency. The graph on the left shows gain, OIP3, and P1dB performance versus frequency, and the graph on the right shows gain versus frequency and temperature for the ADL5535. The ADL5534 dual IFA is featured in the circuits from the lab article that shows how the IFA can be used as a high-performance fixed-gain ADC driver. Please visit www.analog.com/RFamps to download the entire article. ADI's driver amplifier family offers products specified for both narrow and broadband operation. The ADL5320 and ADL5321 SOT89 quarter-watt drivers operate across 400 MHz to 2.7 GHz and 2.3 GHz to 4 GHz respectively. The quarter-watt drivers provide very high OIP3 and P1dB specifications on very low power consumptions, while the internally matched ADL5322 and ADL5323 half-watt drivers operate across 700 MHz to 1 GHz and 1.7 GHz to 2.4 GHz respectively in a compact 3x3mm LFCSP package. The ADL5320 driver amplifier achieves excellent ACPR performance. At an output power of 10 dBm, the ACPR is still very low at -70 dBc, making the device particularly suitable for PA driver applications. The ADL5320 also provides 42 dBm of OIP3 and 25.7 dBm of P1dB at 2.14 GHz on only 104 milliamps. ADI's newest driver amplifier is the ADL5604 1W. At 2.63 GHz, the ADL5604 achieves a gain of 12.2 dB and an OIP3 of 42.2 dBm to deliver a P1dB of 29.1 dBm on only 318 milliamps of current. The driver covers a wide frequency range of 700 MHz to 2.7 GHz with minimal external tuning. The small 4x4mm LFCSP package helps save board space, and the driver has the ability to be powered down and up quickly in 50 nanoseconds for TDD applications or applications requiring power saving modes. This graph shows that the ADL5604 1W driver amplifier can deliver 15 dBm power out while achieving -60 dBc ACPR on only 318 milliamps of current. The last family of amplifiers are the RF-IF gain blocks. These amplifiers are internally matched and operate over a very wide frequency ranges of up to 6 GHz. They are optimized for high OIP3 and low noise figures, giving them extremely high dynamic ranges over frequency on very low power consumptions. The ADL5541 and ADL5542 gain blocks have higher linearity at higher frequencies than the competition. The graph on the left shows S parameters versus frequency, and the graph on the right shows gain, noise figure, OIP3, and P1dB versus frequency. These gain blocks are also offered in the compact 3x3mm LFCSP that saves a significant amount of board space over other common package types. The ADL5601 and ADL5602 SOT89 gain blocks have the highest dynamic range on the market today by providing extremely low noise figures and very high OIP3 specifications simultaneously. The graph on the left shows OIP3 versus frequency and output power, while the graph on the right shows noise figure versus frequency and temperature. This is a quick reference summary of all the amplifiers we've discussed today. ADI's latest RF-IF amplifier brochure can be downloaded from www.analog.com/RFamps. And the last page of the brochure includes a detailed product table separated by amplifier type. Here we show which amplifiers require minimal external tuning and which are internally matched and only require external decoupling. As you can see, ADI's amplifier family focuses on reducing external component count to reduce board space and system cost.